Today we are looking at powers and exponents and using repeated factors. So a power is a product of repeated factors. And then there are two different parts of a power. We have what's called the base, and that is the repeated factor. So that's the number that you're multiplying over and over. Then we have the exponent, which you'll know is the little number that you see in the top right corner. And that exponent indicates the number of times that we use the base as a factor, or the number of times we multiply. So here's an example of a power. So this whole thing here, that's called the power. Okay, you could read it as 2 to the 4th power, 2 to the power of 4, and then we have the base, which is the 2. Okay, so the base is the 2. The exponent is that little 4 in the top right corner. Okay, so this does not mean 2 times 4. This means 2 times 2 times 2 times 2. Okay, so 2 is used as a factor 4 times. So over here in this chart, you can just see some different ways to read the powers and kind of how it's written out, and then what we would call the value. I use the word value instead of answer. Okay, you're finding a value here. And your answer could vary based on what the question is asking you. When you have 4 to the 2nd power, a lot of times we say 4 squared, and 4 to the 3rd power, we will say 4 cubed. These we'll visually see why we call them that when we get to geometry and deal with area and volume. All right, so we are going to write these products as powers. So to do this, I can see here that my base is going to be 4. And 1, 2, 3, 4, 5, I'm multiplying it 5 times. So I put 4 to the 5th power. This one, my base is going to be 12. My exponent is going to be 1, 2, 3. 12 to the 3rd power. Okay. Go ahead and pause the video and try the next two for me. Okay, we have 6 to the 6th power, and then 15 to the 4th power. Okay, now, so that one here, that was writing the product as a power. So you're taking the product, turning it into a power. Now we're going to do something where we're going to find the value. So now we're kind of doing the opposite. We're going to take this power, and we're going to, instead of 7 squared, I'm going to write it out as 7 times 7. And then I'm just going to find the value. 5 to the 3rd power, I'm going to write that out as 5 times 5 times 5. Okay, and then I can kind of lump these together and think, well, that's 25, and then multiply by 5 again. 125. Go ahead and pause the video and try the next two for me. So here we have 6 times 6 times 6. I know 6 times 6 is 36. Multiply it by 6 again. And I use some mental math strategies here, and I know 30 times 6 is 180, and 6 times 6 is 36. So if I add those together, I get 216. Okay, 9 squared, that's 9 times 9, so 81. Okay, flip it over to the back side. Now we're going to talk about something called a perfect square. The perfect square is just the square of a whole number. So what that means, if I take a whole number and square it, such as 1 squared, I get 1. 2 squared, 4. 3 squared, 3. 4 squared, 16. 5 squared, 25, and so on. So these numbers here, those are called perfect squares. Okay? The reason they're called perfect squares is because if I take 5 squared, and I put 5 rows of 5 like this, or a 5 by 5, it's going to make a perfect square. So that's why we get that term. That's where that term comes from. So down here, we're going to determine whether these numbers are perfect squares. You're not simply going to write yes or no. You need to give me an explanation. So 64, I know that 8 squared equals 64. So that means 64 is a perfect square. Because I can take a number and multiply it by itself to get 64. So it is a perfect square. For the number 20, there is no whole number squared that's going to get me 20. Okay, 4 squared is 16, 5 squared is 25. There's nothing in between there that's going to get me to 20. So no whole number squared equals 20. So 20 is not a perfect square. Okay, so we're going to go ahead and try a word problem here. We have a game board here. It's a Monopoly game board. It is a square, and it has a side length of 20 inches. So the reason I marked that knowing it's a square is important because I only know one side length. But if I know it's a square, then I know all 4 side lengths because they're all going to be the same. And then I'm going to put a box around the question. Okay, what is the area of the game board? So if I'm finding the area of a square, that is side length squared. So my side length is 20. I'm going to substitute that in there. So remember, that's not 20 times 2. That's 20 times 20. So that gives me 400. Now I need to go back to the question that I boxed, and I need to answer that in a complete sentence. So what is the area of the game board? I'm going to say the area of the game board is 400 inches squared. No naked numbers here. Now, if you wanted to simplify that 400 inches squared, you could write it like this, 400 inches squared. However, you cannot write it like this. That would mean that we're taking 400 squared and labeling it with inches. So this one is a no, this one is a go.